So we're going to do 4.6, which is analyzing quadratic functions in the form that. Okay. So basically you have questions that look like this. This isn't vertex form. We basically, it's the least useful form because looking at this, it doesn't really tell you very much information. The only really thing that it tells you is this number at the end is the y-intercept. But as you probably realize from when you've graphed parabolas, the y-intercept isn't really important. It's important in some word problems, so it can be helpful, but graphing the entire graph, you need the vertex or you need some zeros. So we actually have to change this form. Anytime you see it, you need to change it. You could change it into vertex form, and the way you would change it is by completing the square. We're not going to do that. We're going to change it into a different form, which you haven't worked with a lot. Okay? If you saw this, okay, you've seen this before. This is actually a factored equation. So your textbook doesn't call it this, but I call this factored form, a factored form of an equation. It's helpful. The reason it's helpful, this number at the front, just like when you had vertex form, something like this number at the front is your a value. That tells you the stretch. So it tells you if it's a stretched out parabola or a squished parabola, if it's a smiley face or if it's a frowny face, whatever. Okay? That's not different. What is different is these two numbers here. These two numbers are, which hopefully you remember, the zeros. So, for example, if I wanted to graph this on my graph, I have a +2 here, which is actually here, the -2. And then I have -5, and it's actually +5. Okay? I know it's y equals 3 is a positive number, so I know it's going to be a smiley face parabola, and that would be my estimate. Now, the only thing is that from here, I don't know where the vertex is. And what we're going to learn today is how to find the vertex using this. Okay? Cool. So let's actually do that. So if we have factored form, if we already have this equation, we want to find the vertex. The way that we do that is we try to find what's the number in between. So if I look at these two numbers, if you use a graph, you can just count and kind of see it, but we want to find what number is in between. We want to find the axis of symmetry. Okay? The way you do that is you average the two numbers. So 5 plus -2 divided by 2 is going to be 3 over 2 is going to be 1.5. So I know my axis of symmetry is going to be right along 1.5, which is about here. That was not a straight line, but you get the idea. It's going to be there. Okay? So I know the axis, the line would be somewhere around here, but I don't actually know where yet. What we're going to do, we know that this is the x value of the vertex. It's going to be somewhere like down here. So what we're going to do is we're going to sub this. We're going to sub this value into the original equation. Then it's going to tell us where exactly it is. So let's do that. So I have y equals 3, 1.5 plus 2, 1.5 minus 3. Now when I simplify this a little bit, it's going to look like this. Sorry, that was a 5. -3.5. All right, now when we multiply this out, we're going to get, oh, hold on. Sorry, so we multiply this out, 3 times 3.5. And we get 36.75. And the kind of nice thing about this is that we knew that the value is going to be down here in negative value. So if you forgot to use that negative like I did, you're going to realize, wait, it couldn't be up here. Oh, it's actually going to be down here, negative value. That's where I'm going to plot it. So it's interesting because looking at this graph, my vertex is actually going to be way, 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 way down below. Okay? So I would have to actually graph that point and then show it or change my scale so I could fit it on there. But now we have the vertex. These are the x and y values of the vertex, and we have 2 zeros. That is sufficient to graph. You have 3 solid points. You don't need to use step method. The step method is when you use the vertex form. Okay? That's factored form. That's how to graph it. Now, let's go over how to create factored form. So let's say we had this example right here. Oops. Okay? If this was our equation, my goodness. That's our equation. before you even try to put it into factored form, we want to first realize, does it actually factor? Because we could try and do all this factoring stuff, and you could end up getting a parabola that looks like this. This doesn't actually have any zeros. So this equation in factored form won't work. You would have to use vertex form. So what we're going to do is we're going to use the discriminant, which is why we learned how to do that before, right? We're going to do the square root of b squared minus 4ac. Okay? Sorry. So let's sub in the numbers using this equation. This is A, this is B, this is C. So when we sub in 1.5 squared minus 4ac, so 4, 0.5, negative 5, I can tell right away this is going to be a positive number, okay? Because it's got a negative times a negative, so it's going to be some positive number, so I know it's going to factor. So I don't need to do the rest. If you end up doing the rest, you'll see that it's a perfect square. Okay, so we can put the numbers in. 1.5 times 1.5, 2.25 minus 4, 10. So it's not a perfect square, it's going to be some weird decimal. So if it isn't perfect square, we got to use the quadratic formula. You use the quadratic formula, and it's going to tell you what the roots are going to be. If it is a perfect square and it factors nice, you factor it and create factored form. Okay? There are going to be other questions where it gives you clues, and you have to use those clues to actually write out the equation. So for example, it says it goes through this point and the zeros are these two. So I'm going to start with my equation. Okay, these two numbers are my zeros. So I'm going to put the numbers in, and remember, it's always backwards from what it should be. So if this is 1, it's actually going to be negative 1. This is 7, so it's going to be negative 7. Now the only thing, I don't know what this a value is. To find the a value, I have to sub in this point. And remember, this is xy. So I'm going to sub those numbers. So this 3 is going to get subbed into the x's, and the 16 is going to get subbed into the y. So it becomes 16 equals a, 3 minus 1, 3 minus 7. 16 equals a, what's that, 2, and negative 4. 16 equals a times negative 8, and then divide both sides by negative 8, and you get a equals negative 2. Cool. So I found my value. So my final answer would be y equals negative 2 for the a value, and then x minus 1, x minus 7. That would be the final equation that satisfies these requirements. So now, the big question is, which is better? Factored form or vertex form? I'm going to be honest, it depends on what you're trying to do. So ultimately, we're trying to get you ready for word problems. With word problems, a lot of questions will ask for different stuff. So sometimes it'll say like, oh, what's the maximum height of a ball you threw? So what you want to do is like, imagine your parabola before you do anything and just think, what do I want to know? If you wanted to know the height, the highest point, well, that's the vertex. So you're probably better doing vertex form. But if something's asking like, what's the width or the length of time it takes for the ball to go from the start to the end, well, those are zeros. So it might be better to do factored form. If it's not a word problem and it just says graph it, honestly, I find that both methods work, but it depends on which skill you're better at. For vertex form, if you like to complete the square, that's what you want to do. For factored form, if you like factoring, or you like using the quadratic formula, that's going to work for you. Now, the safest one is to use the vertex form because it always works. However, if you try and do the factored form and it's a parabola that doesn't have zeros like this, it won't work. So I kind of lean towards using factored form unless it's really obvious that it can factor, okay? Although a lot of questions on tests are just going to say use factored form, use vertex form, whatever. Let's do a sample word problem, okay? A parabolic shaped door, so like that, right, is 2 meters wide at the base. 0.5 meters from one side, so like if you go in a little bit, it's 3 meters tall. We need to write an equation to model this door. So let's do it. It's 2 meters wide at the base. So I'm going to sketch a parabola really fast just so I can understand what's going on. That means that this is one of the zeros, and this zero is at 2 meters away. I now have enough information that I can actually write the equation. So I'm going to write y equals a, x minus 0, x minus 2. Because I can see these are my x-intercepts. My x-intercepts are right there. So now I don't know what the a value is. So I'm going to use these numbers, this point, to solve it. So it says 0.5 meters from one side, so that's going to be here, which is the x value, 0.5. The door is 3 meters tall, which is like up here, 3. I'm going to sub these two numbers in. So 3 is equal to a, 0.5 minus 0, 0.5 minus 2. You don't really have to write the 0. I like writing it just so I remember that I wrote something. Now let's sub in the numbers and solve. So 0.5, negative 1.5, cool. Now let's actually multiply 0.75, negative 0.75, and then divide both sides. Okay, and I'll end up getting negative 4 equals a. Now let's just do a quick double check. Does it make sense that we have a negative value for a? Yes, it does, because you have a door shape, right? Doors are like this, so it has to be a frowny face. It makes sense. So now I have the equation. I'm just going to write the actual equation. Y equals negative 4 x minus 2. So I rewrote this equation. I just actually had a number for a instead of just an a. Now, the last part, the challenge part. Does a 3.5 meter item fit? So let's think of what that means. That's probably the width or the height. Obviously the width, it doesn't fit because it's only 2 meters wide. So we'd have to see if it was like 3.5 meters tall, does it fit in the door? Now let's think, what does 3.5 meters mean? Well, that would be the vertex. So in order to find the vertex, we're going to use the strategy we figured out before. I'm going to say, okay, let's find the vertex. In between these two, the axis of symmetry, I don't even need to calculate. It's going to be x equals 1. Let's sub this into my equation to find the answer, to find the vertex. Y equals negative 4. 1 minus 2. Y equals negative 4, 1, negative 1. Y equals 4. Cool, I found the value. So this vertex is going to be 1, comma 4. So looking at that, would this 3.5 meter item fit? Well, it totally would, right? It's 4 meters tall, so it would fit with space to spare.